All right, here we're going to be taking a look at y equals secant of x, and we're going to try to generate this graph not from memory but by using the points on the unit circle. So when one thinks of secant of x, we quickly realize that secant of x is the same thing as the reciprocal of cosine, so it's 1 over cosine of x. All right, so if I just go through and highlight the cosine values of my quadrantal angles, this may give us enough information to sketch a graph of this thing. Okay, so if I take the reciprocal of, so at 0, the cosine of 0 is 1. If I take the reciprocal of 1, it gives me 1. At pi over 2, the cosine is 0. If I take the reciprocal of 0, I get 1 divided by 0, which is undefined. For negative 1, the cosine of negative 1 is negative 1. And again, for 0 down here, 1 over 0, the reciprocal, that's also undefined. So if I translate that then to my, graph here, 2 pi, just the quadrantal angles here, and I plot some of these points, at 0, we have a value of 1. So when the angle is 0, it's at 1. At pi over 2, this thing becomes undefined. So there is an asymptote. Let's just draw the other asymptote at 3 pi over 2. That was undefined. At pi, the secant value is a negative 1. And at 2 pi, back up at 1. All right, now this is not enough to graph, but here's the thing. This should not be a total surprise. There is a relationship to a cosine graph here. If I were to graph a cosine graph, let's just put it in a dotted line here. It's really not part of the secant graph, but here the reciprocal of 1 is just 1. The reciprocal of negative 1 is negative 1, right? So that's why these points appear on the graph, because the reciprocal of 1 is 1, the reciprocal of negative 1 is negative 1. But look, where the graph crosses the x-axis, that's an output of 0, and the reciprocal of 0 we said was undefined. So it shouldn't come as a surprise that we have asymptotes at pi over 2 and 3 pi over 2, because that's where a cosine graph crosses the x-axis. All right, well, we're going to have to fill in points for some of these other values here. Right, now this could take a while, but we're not going to do it all in this video. But if we just do the first quadrant, right, the reciprocal of radical 3 over 2, that would be 2 over radical 3. This would be 2 over root 2, and this would just be 2 at pi over 3. And so those angles on the x-axis, there might be pi over 4, there's pi over 6, there's pi over 3. And when we fill in those values, what happens is we start noticing the pattern. Right? These values start taking on a pattern, and this is going to shoot up this way. If I were to do that with all these other angles in quadrant 2, right? If I were to fill in all these other angle measurements here from pi over 2 to 3 pi over 2, and keep going all the way back to 2 pi, we're going to notice this another pattern. It's going to start doing something like this. And so it's going to come up this way and shoot back down here. It's going to hug those asymptotes. This one's going to come up something like this. It's going to come like that. So that would be one cycle of a secant graph, and we can generate that right from the unit circle. So if you're ever in doubt of where those asymptotes are, or how the graph behaves, you just go back to the unit circle and plot a couple points. It would be a good exercise for you now to try to do it with a cosecant graph. So take this unit circle, sketch a new graph of cosecant, use the sine values, because cosecant is the reciprocal of sine. Use the sine values and see what you come up with. And then you can check yourself on the video.